So just before we continue on, I just want to draw your attention to I made a slight mistake just in labeling the positions of where my outputs are being wired into. So just comparing that to our wiring diagram, I had them listed in the wrong ports in TIA. So it's just to make sure that they match up correctly. So you'll see the deflector is in at 0.1. So that should match up directly there, 0.1. Okay. And then the other thing I forgot to tell you is we'll need the data block created to store a position variable, which I'll talk about in a little bit. So how you do that is just double click add new block, click on data block and click OK. And then that will give you this data block in which you can type the variable, which is going to store the position of your sequence, the kind of step number of your sequence. So you just call the position, make sure it's an integer, and it starts off with the 0 value. So I'll talk about that a little bit now in a minute. So there's just a couple of tidy things to tidy up in the setup from the previous video, just to make sure that we're okay. Now we want to talk about the process and the steps of our sequence. Okay, so how it's kind of written out, how we can write it out so that we can use it to check our code, use it for fault finding, and to keep us right. So you always try and, you know, when we start off, we're listing out our inputs and outputs. We're always trying to, you know, understand an overview of the system and see how it's going to play out really. So I've put together a nice little table that's given us a step number. Okay, and I've talked about these step numbers before and the ideas behind them and why we go up in 10s to 20, 30 and 40. So I'm not going to spend too much time on that. But basically what we're doing is we're just giving ourselves a list, kind of a flow chart nearly. It's a table of operations, whatever you want to call it, even some pseudo code, just to give us an idea that we can quickly refer to and something that's on paper that we can constantly check and fault find as we need. Right, so what am I saying, right? Well, I have two variations, okay? I've got a metal product and I have a plastic product, okay? Now my sequence is going to happen over pretty much 5 steps, okay? So I've done that for both of them, whereas you see some are just a little bit more active than other, depending on the product, right? So what I've said, well, you know, step 0 is rest. So everything is at rest. You know, we've no pucks here. We've no, the cylinder is retracted, motor's off. Everything's at rest, just kind of stationary like this. So then I want to say it, well, at step 10, at my first step, what I want to happen is I want the motor to turn on and I want A to extend. So once we've satisfied a condition to go into 10, so that there's a part here, we've pressed the start button, cylinder's retracted. Once we do that, we'll go into step 10 and the motor will turn on and A will extend. So the motor will turn on, A will push the puck into the conveyor and the conveyor will bring it along with it. And then once we are in step 20, what I want to happen next is A to retract. So once we get the full extension of this, we'll hit the maximum limit of the sensor and then we want it to retract. So it'll just pretty much come out and back in those steps. So A will then retract. Then if we get step 30 triggered, so what I'm saying is if the inductive sensor gets triggered at this point, we're going to go into step 30. And that's for the deflector to operate, so to come down. Okay, no, plus seems like it goes up, but what we mean is that to be activated. So that will close down, motor is still running, so it'll still keep it, and it will knock it into position. And what I want is I want a bit of a, you know, 2 or 5 second delay, whatever it is, just a bit of a delay, and then we will go into step 50, which is going to bring us back into rest pretty much, that D will retract and M will retract as well. Okay, or so sorry, D will retract, so the deflector will pop back up, and then what I mean by M retracting is just basically the motor will turn off. So I've wrote that out in my steps and how I want it to play out, and that's for a metal product. Now there's a slight difference with the plastic product because it's not going to trigger this inductive sensor, and we don't want it to essentially go down the slide here. Okay, So same thing's going to start at the start. We get to step 10, we're going to put the motor on, then A is going to extend, then A will retract. So essentially the plastic puck is moving along here. Gets to this point, it's not going to activate the inductive sensor. So therefore it's not going to go into these steps. So that's why I've left them blank. So the next thing that's going to happen is really it's going to pass underneath here and it's going to trigger this optical sensor. And what I want then is that optical sensor will just move me into step 50. So it'll move me from step 20 into step 50. So rather than going from step 20 to 30, it will just jump to 50 and it will turn my motor off. Okay, so that's basically the analysis, the setup into planning how we're going to solve this system. And we can refer to this, it will keep us right for the code. So we'll jump into the code and we'll start doing a little bit of work on that now.